Securing data. In today's digital age, data security is a top priority for organizations worldwide. As threats continue to evolve, so too must the strategies and techniques used to safeguard valuable data. In this lesson, we're going to jump into the various methods used to secure data, including geographic restrictions, encryptions, hashing, masking, tokenization, obfuscation, segmentation, and permission restrictions. First, geographic restrictions. Geographic restrictions, also known as geofencing, involve setting up virtual boundaries to restrict data access based on the geographic location. This method can help organizations comply with data sovereignty laws and prevent unauthorized access from high-risk locations. For example, if all my employees are located within the Americas, I can simply ban any login requests originating from Asia or Africa, as my users can never be logging in from those locations. Second, encryption. Encryption is a fundamental data security method that transforms readable data, plain text, into unreadable data or ciphertext using an algorithm and an encryption key. Only those with the corresponding decryption key can revert the data back to its original form. Encryption is crucial for protecting data at rest and data in transit. Third, hashing. Hashing is a technique that converts data into a fixed size of numerical or alphanumeric characters, known as the hash value. Unlike encryption, hashing is a one-way function. Once data is hashed, it cannot be reversed or decrypted. Hashing is often used to store sensitive data, like passwords, and it's also used to check the integrity of files. Next up, masking. Data masking involves replacing some or all of the data in a field with a placeholder, such as X, to conceal the original content. It can be done partially to keep some metadata for analysis. For instance, in a phone number, the area code might be kept, but the rest of the number is replaced. Data masking can also maintain the original format of the field. Once data is masked, it's a one-way process, so it can't be reversed, making it a method of de-identification. Next up, tokenizations. Tokenization replaces sensitive data with non-sensitive substitutes, known as tokens. The original data is stored securely in a separate database, with the token serving as a reference to the original data. Tokenization is commonly used in payment processing systems to protect credit card information. Next up, obfuscation. Obfuscation involves making data unclear or unintelligible, making it difficult for unauthorized users to understand. This can involve various techniques, such as encryption, data masking, and the use of pseudonyms. Next up, segmentation. Segmentation involves dividing a network into separate segments, each with its own security controls. This means that even if a cybercriminal gains access to one segment, they cannot move laterally to other parts of the network. This limits the potential damage of a breach. Finally, permission restrictions. Permission restrictions involve defining who has access to specific data and what they can do with it. This is often managed through access control list or role-based access control, often known as RBAC, by limiting access to only those who need it. Organizations can significantly reduce the risk of internal data breaches. So, in conclusion, securing data is a tedious but rewarding process that requires a combination of techniques tailored to an organization's specific needs and the nature of the data they handle. By implementing a robust mix of geographic restrictions, encryption, hashing, masking, tokenization, obfuscation, segmentation, and permission restrictions, organizations can protect their valuable data assets from both internal and external threats.